warm welcome to today's lunch lecture. My name is Evelina, and I'm here with Unga Mot Multiresistens, or UMM. It's a Swedish youth organization that cares about antibiotics resistance. Thank you for being here to discuss a very important topic that really affects all of us. For those who might not be familiar with antibiotics resistance, I can just explain a little bit what it is. This is something that happens when bacteria become resistant to antibiotics. So some infections that we can treat today might become very difficult or impossible to treat in the future. And this is often described as one of our greatest global health threats. Hello, welcome, of our time, yet it's still an issue that surprisingly many know nothing about, or very, very little. So that's the one reason why we think this is very important to create spaces like this where research, innovation, and societal discussions can come together. And just quickly about us in UMM, I have some from the board here today also. We work to spread awareness about antibiotic resistance, or AMR as it's called, antimicrobial resistance, through social media, lectures, collaborations, and events like this. And we want to increase knowledge and engagement regarding this issue, because this is not only a question for researchers and healthcare professionals, but also for all of us. It's something that we all should care about, since it's our shared future. So if anyone finds this interesting and want to learn more and get involved in this, maybe collaborate with us or just become a member, and talk to us afterwards, and follow us on social media, and you will learn more. And before we continue, we also want to thank the KTH Library for hosting this with us. But now we will move on to the panel discussion. So we are joined by 3 different researchers here from KTH, approaching antibiotic resistance from different perspectives. So we have it including diagnostics, treatment, and decision-making. And we will talk both about the challenges that we face, and also the solutions that are currently being developed. So with that, let's get started. I welcome up our moderator Alvi, as well as Hena Marino Migueles, Michael Malcock, and Emre Iseri. So please, let's give them an applause. And you can sit like this, so it's easy for people to see who is who. And then for you, Emre, I put a little microphone there. Maybe you can just have it there, and then.
Hi, welcome. So glad that you're here today. Just shortly, in a minute each, about what does your research focus on regarding antimicrobial resistance, and why does it matter in this fight we are currently facing? All 3 of you, please begin.
Yeah. Okay, we passed it. Hi, so I work on sepsis diagnosis. So for you that don't know what sepsis is, when you have an infection and your body overreacts to it, and then you become in a very critical condition. So what we are trying to do right now, because the current diagnostic process takes a really, really long time, we are trying to separate the bacteria or the pathogens from the blood, and then characterize them so that we can get the antibiotic profile on them. And as Evelina said at the beginning, before we had some diseases that you could just give a certain, like a broad spectrum antibiotic, and it would be no problem. But now with the high rise of antimicrobial resistance, we can have some of these cases that are not able to be treated with broad spectrum antibiotics, and your patient is very critical. So then you want to be able to do this in as short as time as possible.
Do you want me?
Why? Yeah, I can.
Go.
Yeah, my research focuses on urinary tract infectious diagnostics. and we have been developing a test to use at the doctor's office or closer to the patient, maybe in the future at the patient's home. Why it's important? Because UTIs is one of the most antibiotic prescription cause today. And if you look at it, arguably it's the one that is most often wrongly treated, because today people don't do tests. If you go with the urinary tract infections to the board central today, they will prescribe antibiotics based on the symptoms. Even in Sweden, although Sweden is one of the best countries when it comes to antibiotic prescription. So that's why we are trying to put a test closer to the patient that can help to diagnose if there is a bacteria in the urine, and if there is a bacteria, to understand which antibiotic will work best for it. So my research focuses on that, and we have a spin-off company 4 years ago. At the end of my PhD, we started, called Utilizer, and we are now trying to commercialize the first test to the market.
Thank you. And I'm Michael Malkosh. I'm a professor at the Department of Fiber and Polymer Technology. My focus is on designing novel materials or precision polymers that can be used as alternatives for various life science applications. And in this context, it's about having alternatives to antibiotics or infection-related treatments. Yeah. So what do I do? Well, my research is literally designing these highly charged nanomaterials that literally can scavenge bacteria. They can be sprayed on an infection. They can be embedded into a wound dressing. And literally, if the bacteria sees it, they will love it. They will go there and they will get stuck and then they will die. They don't discriminate if it's gram-positive or gram-negative bacteria. Extremely efficient technology. And I do hope it will be an alternative in the future for existing solutions when you do, for instance, surgery.
Thank you very much. It's all such interesting areas that are so important right now and will be in the future too. So what you're doing is amazing. And the next question that I have for all of you is that we know that one of the major drivers of antimicrobial resistance is that, or in regard to antibiotics, is that it's taken when it shouldn't, like you said a while ago. From your perspectives, what needs to change for this to actually improve? That we no longer, or can decrease when antibiotics is used forcefully or preventatively when it doesn't have to, and it can create this resistance.
This is for everyone. So I think diagnostic is very important. I think in Sweden even, I have small kids or a bit older, but several times you would get, antibiotic based on the symptom. So you have your kids eating, covipenin, which is a typical antibiotics, and then 4 days later, after they've done the test or whatever, they call you, say you got the wrong antibiotics. You have to come back and you have to do this. So suddenly you are actually making this even worse. So I think diagnostics is extremely important. I can just tell you now, we are writing this big application about infections and how to do the future treatments. And you can see the statistics over how many people have died in Europe based on AMR. And two countries literally spike, and that is Greece and Italy. So it tells you a lot where people are very generous with using antibiotics. Nordic countries are on the better side.
I think it's from that point, it's really related to societal differences. A lot of the education-wise and different perspectives on different countries takes it differently. And from the when you look at the technology perspective of it, I think technologies are all exist. These tests are available. When you send the samples to the hospitals, they will do the tests. And when I approach from the urinary tract infections perspective, they take the samples from when patient go to the doctor's office, they take the samples and ship to the central laboratory. but then laboratories take 2-3 days to answer, as is in your case. And for some cases, like children's case, people don't want to wait. Families are worried. People are worried about their children, so they want it to be treated. And I think Sweden is a little bit less pressure on doctors, but if you look at the South European countries or in Asian countries, you will see lots of pressure on doctors, so that they just want to prescribe it so that they are on the safe side. But that fuels the antibiotic resistance problem. So people keep using antibiotics, and naturally the bacteria develop resistance to it, because it's from evolutionary perspective, more you use it, more bacteria will appear to be resistant on it. So you cannot stop the resistance. Resistance is only be slowed down if you treat it rightly. So that's the most important part, and that's why we are focusing on diagnostics, to be able to prescribe correctly from the beginning, or if it's not needed, to stop prescribing. So that's our focus.
Well, I think you guys have covered basically also what I was going to say, but for sure, fast diagnostics are a main part of it. And if I can chip in maybe with, I'm originally Spanish, so with my perspective of how that is here, as we mentioned, like in the Southern European countries, there's a bit more of a rise of resistant strains. And my experience both living in Spain and in Sweden is that here is extremely difficult to get antibiotics unless we are really sure that you have something going on, whether in Spain is a bit easier. And also they give you larger amounts of antibiotics, and people are really not sometimes educated in the fact that, oh, the antibiotics that you get this time, you should finish it now. And then people also self-medicate. So that goes a little bit with the education that I think is very important, to have a population that really knows about the problem of antibiotic resistance, and it is highly educated on how you should be treating antibiotics, and like the risks if you're like self-medicating and so on. So I think that and fast diagnostics.
Thank you once again for the insight regarding this. And the next question that I would like to ask you is even more a deep dive into what you're currently doing, because you approach AMR from different angles, both diagnostics, treatments, and decision making, and what needs to be done regarding it. And how do you think that these approaches complement one another? I think you have covered quite a lot about how the initial steps regarding it, but how can we work together even more to tackle antibiotic resistance, you believe?
Let's do it reverse this time,
Ah.
so you don't
Yeah.
say with the
So this is a tricky question. I don't really know how to answer it, but I think first thing that came to mind when you said that, going back on what Michael said before, that you're putting dispatches and the bacteria migrate to them, right, and then they just die there. Perhaps that's a way of prevention rather than diagnosis. So if you prevent an infection, then you don't need treatment afterwards. And then I think Emre and I are working on something that fairly overlaps, right? It goes about fast diagnostics and how to prescribe your patient with the right antibiotics. So, but I don't think I really have a good answer on how I would put the three technologies together. But for sure, prevention and diagnosis are both a good approach that can go hand in hand.
I would say the answer is more falling on the higher level. It's about politics and it's about economics, because that's the main bottleneck here, not the technology. There are lots of research, lots of cool technologies appearing, but when you try to change these things, like when you want to put a new test or when you want to run these things, it all comes down to the economics, and economics are decided by politicians. And there are lots always, in the shorter term, there are lots of other priorities over this, because this is a long-term effect. So it will not happen tomorrow that it will kill you. It's estimated to be 2050, 2070 if we don't take any action, it will be disastrous. But today, when you look at it, politicians only look at short term, their next elections. They look at it to just make an impact quickly, so that they don't prioritize these things. Because no matter what we do and how much good technologies that we develop, if it's not taken and used by people, it's not going to make the impact. And that's, I think, the bottleneck today. So you cannot really change it on your own. It has to be societal. That's why I think this is very important that you are starting this and focusing on this, because it needs to really come and drive from the societal level to pressure up to have this change. People need to demand this, and they need to, for that, they need to have, they need to have the basics first. And in Sweden, maybe it's a good place because, everyone has some wealth and, they have a good living standards. But when you look at, since it's a global problem, when you look at the Far Asian countries or African countries where, they have basic needs first to solve. So they wouldn't care this. They would just use the antibiotics if they have it. If they don't have it, they don't use it. But the moment that they get the pills, they will not question it. So adding another layer to increase the cost for diagnostics is going to be very tricky. So it needs to really come from global perspective and economical perspective to the next step.
Yeah, I don't know how to answer. I can answer it from different angles. So one can say that well, how would I describe this? If you look on how many antibiotics or how many new innovative solutions there's out there that can address AMR, you will see there's not that many. And if you look on the what type of cause do researchers now apply for, you will see that a lot of the calls are out there. They will ask you to formulate existing antibiotics to make them better. Now, this could work probably, but it's still the same mode of action. So that will not be something that is, I would say, sustainable for the future. So to install a new innovative technology, if it's in diagnostic or if it's infection control, you really need to have the right momentum. That's where politician comes in. You need to see more people dying. So people need to die. And the more they die, the more acute it will be. And therefore, it will accelerate. Unfortunately, this is reality. This is how it will be. And then you will see more and more initiatives. In the end, if you are going to the hospitals and you are going to, let's say you have a multi-resistant bacteria, and there could be like a couple of last resort antibiotics to use or a growth factor. If those fail, you're screwed. There's nothing else to do about it. Are there innovative technology out there? Yeah, absolutely. Are they available? No. Why not? Well, nobody invests in them because investors don't give a damn if it's not something that is already on the market. So any technology that would be available for treatment, not diagnostic yet, it's so costly that investors are not actually, we were talking about it earlier, they are actually not pushing that angle because they just see short-term investment, they want to get it. So the future in AMR is going to be related to death. More death will end up being giving more momentum.
Maybe I can add a point there, if I may.
Certainly.
So on the treatment side, when you look at today's landscape for new antibiotic developments, pharmaceutical companies says that every 1 in 10,000 molecules are really found to be effective and goes into clinical phases like a 3-4 phase to become an available drug on the market. And when you look at from the investment side, how much money it takes, it's like maybe close to hundreds of millions, if it's not $1 billion, need to be put into the new drug developments. And when you look at the return of investment from the pure money perspective, it's not that high. It's like, if you get lucky and 1 out of 10,000 times your molecule is working fine, you get 28 times estimated, 28 times money return of investment. So it's basically buying a lottery ticket, and they don't do that. They just bet on safer things. And that's why you see a slowdown in new antibiotics to be developed, because economy drives it. So you don't really get new drugs on the market. And with today's awareness of not using antibiotics, their market is getting smaller. So pharma companies don't like it from the money perspective, but they have to do something societal perspective, because they need to be nice to their, because they are on the stock market, or they are living with these governmental deals or societies, so they have to be nice to people. But from pure economical perspective, it doesn't make sense. So that's why maybe there are lots of initiatives that are trying to be taken by WHO or the governments to feed more money into the research, but it's not enough, because in the end, even if you pour in money in researchers to develop new molecules or new antibiotics or new antimicrobial technologies, it's a low chance that one of them will become a product, and it's not enough to reach that with the existing funding landscape.
Thank you. It sounds like there is a societal urgency needed for this to actually, something to actually happen almost in the future. And maybe that's what that's what needs to happen before we actually find something, find a solution to all that's going on. Because we need everyone to see that this is a problem, and on a societal level that everyone is engaged. Thank you very much. The next question that I have for you is that, just like you talked about here, that there are many solutions, there are many promising solutions, but they never reach patients, even if they are promising and even if they have been worked on. What do you believe are the biggest barriers to integrating your kind of innovation in the healthcare system? It's a long question.
They say cash is king, yeah? So this is the bottom line. Now, exactly as my speaker here to the right saying, there is definitely a decline on investment into this area. A lot of, I would say, if something pandemic would happen, it would be generated by other regions where they are using less, or they are more frequently using antibiotics, and you suddenly see a rise of a new bug that never existed. And then nothing will probably be of efficiency. In my case, I work a lot on technologies that will be used when a human body is compromised. Yeah? So it could be that you're in an accident, you're driving a scooter, stressful here, and then you get an open wound. They put a patch on it, and then you suddenly get infected. You get a biofilm, and then they don't know what to do about it. So then you would use whatever wound dressing that are available there, silver, etc. And it doesn't fit, and then the infection gets worse and worse. So that is where my innovation comes in. We want to do sprayable solutions that are going to be used, or if you have a fracture, you want to make sure that the implant that you put inside your human in your body doesn't generate an infection. So if you look on elderly, or if you look in, let's say, maxillofacial fracture, the infection risk of getting an infection when you do a fracture treatment is like 30%. This is healthy humans. Yeah, 30%. What do? What they pump you in with a lot of antibiotics. There's no diagnostic there. They pump you until you know you are secure. And maybe it works and maybe it doesn't. So these technologies are something I work on. What I'm scared about is the landscape of getting investors to invest in this. Because again, even though there is a lot of promising results at a preclinical level where we do it in animals, to take it to the next step, which is putting it on a market or making it available for hospitals, you need to pass a lot of regulatory pathways, yeah, or journeys. And there is something in Europe called MDR. Please go and read about it there. It's a nightmare of regulatory for the better for the patient. But Europe is now punished so hard that other regions in the world are actually more progressive and getting more their technology faster to the market. So the European innovation system is now in a very bad position, and they are trying to reverse it. Yeah? So MDR in Europe literally is one of the biggest stoppers for any innovation to push to the market. Yeah, that's what I have to say. Maybe I.
Yeah, I mean, I can take from there. It's really regulatory is one of the big barriers, although it's needed to be regulated because it's healthcare. But recent changes, same as MDR when it comes to diagnostics, is called IVDR, in vitro diagnostic regulatory. So it's very similar from the medical device perspective, that you need a lot of tests, you need a lot of clinical trials, you have a lot of work to do until you can put your product on the market, which obviously is needed because you cannot just use, things that you found in your lab to try it on humans. But on the other hand, that requires a lot of money, and you need to basically create a company of at least a medium-sized company to be able to tackle that, and that requires investment. And as we spoke lately, investment is not so much available in this field because it takes time, because of all these things takes 3 to 5 years, if it's not 10, that someone needs to put in money to your company, and you need to be able to drive this without creating a revenue. So you don't sell anything, you just burn money, and in the end they don't know if you will be successful or not. So it's really risky business. So it needs to be probably more governmental support needed in this field to be able to drive new technologies to the market. I think that's the biggest barrier.
So I think my take on this is a little bit different, but I also work on sepsis that is a little bit like $1 billion problem. So it's something that from the startups that I've talked to working on sepsis is, if you really have a product that works, how they made it seem is like it's very easy to raise funds for that, but perhaps the biggest challenge that they have found, surprisingly, was the end user. So in this case, not really the doctors, but the hospitals. And I think one thing that we don't really think about as researchers is like hospitals, they have these very tight guidelines of how you should treat sepsis in this case. So you get your patient in, and then you do this test, and you do this test, and then you take this decision based on this test. So if you try to now bring in a new test that kind of completely disrupts all of that, you need to convince the hospital or the hospital head, like, oh, this new thing is going to be good. And then you need to really have those kind of doctors that are ready to spearhead this and be like, okay, I'm ready to take the risk and like try this new thing. And I think that's also, especially when you're working on something as sensitive as sepsis, is one of the main hurdles to not only have a great product and raise all the funds to develop the great product, but then to have those end users that are really willing to take the risk and do those trials for you and do all that work so that this can eventually become integrated in the hospital guidelines and eventually used.
Seems to be a combination of both regulatory problems and hurdles to continue forward, as well as the implementation. But thank you. And the last thing I would like to ask is, on a broader perspective, when we're looking forward, if we want to outsmart these superbugs that we are currently fighting and will continue to do if nothing is done, what do we need to do differently, and how can we, students and youth, which are the people that we are mostly closest to us at least, how can we contribute? How do you see that people that are not scientists, but just normal normal students and normal young people that are, what can we do? How can we contribute?
I think you're doing it. So you're raising awareness here. I hope that this is going to be announced. More people will join your group here. I think in general, just being aware of that there is a sleeping, bugs out everywhere. There's always opportunistic bacteria, and the only thing they need is an access point into your body. So by making sure not eating, antibiotics frequently, not doing stupid things, so this is very important. And obviously, age plays a huge role in what type of other diseases you have. If you are young and you get an infection, you can survive it. If you are elderly and you are immune compromised, that would be a much worse situation. And then just being engaged, and maybe influence politicians and investors, etc. I'm a realist. Yeah, I'm a realist. Literally, something big must happen before things will start accelerating. We would not have got the COVID vaccine if it wasn't a pandemic. We could have just waited for ages to get the mRNA vaccines out there. Yeah, I think this is a great initiative, and the more of you, reaching out to the society, the better momentum we will have for the future to tackle any bugs that comes. Because innovations are there, to be honest. I have at home a little wound dressing fused with my technology. If I ever get a really bad infection, I will literally put it on my skin directly. Self-test. It's a self-test. It's a self-test. Like, boom, put it on.
I think, as Michael said, it's really, one thing everyone can do is increasing the awareness. And this is what UMM is trying to do. And what you can do personal level, just, when you see someone taking antibiotics, or, your grandmother talks about if it would be an antibiotic, just teach them, talk to them, your parents, talk to them. And you have one big weapon today, it's social media. Instead of sharing TikTok dance videos that you can do on separate, but you can also share things posts related to this and increase the awareness. Just when you see it, like it, share it. I think this is on a personal basis what you can do without a cost, without spending any time. I think that starts there, and then once you get traction, once things raise up, I think it will make the impact. Then you will start seeing that politicians start talking about it. Although they do, but they don't take action. But once the society pays attention to it, once it becomes an election poll question when you do the test, I think that's where you start understanding that is something happening. It's not today. When you do this poll, you wouldn't see a question like this. I think the moment you see more visibility, that is reached to more public, everyone starts talking about it. And it becomes a question of which political, like a global climate change, which decisions are impacting what. I think that's the moment that you can really make a bigger impact by just doing this social media, increase the awareness, talk to people, talk that this is something important for you.
So I completely agree with what you guys have said. I think awareness and education are key things here. Also, don't be shy when you see people doing things that are wrong. If one of your friends, they're self-medicating, don't be afraid to tell them, you should not be doing this. Like, go to the doctor. Like, you probably don't have what you think you have. So I think awareness and just know what you're taking when you're taking it. Be curious about it. Like, ask the doctors. I think many times they're happy to talk and to discuss with you and why they're giving you a medication or not, and just be interested about this. And as Emre said, like, use social media for these things. I think if we manage to increase awareness on this, eventually it will reach politicians, that in the end is the people that are actually able to do something about this. And also as a student, you can always there is a lot of things going around in KTH towards AMR, many groups working on this. So professors are very approachable. So don't hesitate to reach out to them and suggest projects. If you have an idea of something that might work, they're always happy to listen to you and perhaps collaborate, give you an internship, and so on, so that you can sort of contribute in that sense as a student.
Thank you very much. It sounds like we can actually do something if we just work together. To be loud enough that the people that can make a change actually do. A little pressure can be good sometimes. And now I turn around to all of you here. So we have time for 1 to 2 questions. Is there anyone who would like to ask something? The 3 wonderful researchers we have today. Yes?
If you want to do like a PhD or go to the work in a company, I think it's a bright future. If you're interested in this field, there will always be an impact that you can actually provide. Yeah, so there's, we may be a bit realistic here. What is reality if you are as a patient? But I think as an innovator or as an engineer, you can do a lot, to contribute to the society. And the more we build our knowledge and build the arsenal on how to diagnose or how to treat infection, the better we will be, equipped for the future. So I wouldn't be discouraged. You need to just make a choice what you like most. Are you interested in the technology? Are you interested in patient health? And that is how I would approach it. And yeah, as the rest is, there's a lot of brilliant researchers at KTH and beyond. I would love to, have you guys on board. One else.
I think the most important thing is that you need to like what you're doing, right? Of course, if you approach from pure money perspective, go do something in finance. But if it's really something that you feel like, okay, I need to contribute in this, it's definitely a lot to do in this field. From the research perspective, from companies' perspective, there are lots of research going on, lots of new ideas, new technologies, and it's open for brighter, more ideas and brighter future, I would say. I mean, it may sound like discouraging when we talk about all the issues of regulatory, money, all these things. But if you do what you do and if you like what you're doing and if you're good at it, I think there's always good future in this.
And I think joining this type of meetings and networking and so on, it's always a positive thing. So if you like this topic, you also need to think, oh, do I want to do research on this, or do I want to contribute to this, like in already a company that is already settled? And I think always networking helps a lot if you want to get into these topics. And it doesn't need to be necessarily through a PhD or through KTH. You can go to events and meet the recruiters of a company working on AMR and so on that might be able to give you a job, and that's also a way to contribute to that. But of course, if you're a student and you're looking for master theses and so on, also feel free to reach out to the supervisors, because it might also surprise you that when you actually work on it, maybe it's not as fun as it seems. Not to discourage you, a lot of wet lab work. So you also need to love that part. I think this part of talking and discussing about it is great, but you need to. There are many ways to approach it. So explore all of those as well.
I can add something. Because we in UMM, we also think that it shouldn't only be like life science that talks about this. So, and now we have been here at KTH, but we will probably be also collaborating with KI, Karolinska, and Stockholms University. So we will have like a joint event as well. So yeah, we think it's super important that we have all of the perspectives and that we collaborate Thank you so much for the panel. Let's give them an applause. We're round off now, so please have some more feedback. Please follow us on social media for more events, and thank you all for coming. Wish you a good day.
Thank you very much.